See, today we are going to discuss about the stoichiometry. See, what stoichiometry? In this study of quantitative relation between the amount of reactants and products is called stoichiometry. See, when we are finding the relation between reactants and product, okay, how amount reactants have reacted, what are the volume reacted, what are the number moles, we are calculating the mass of products. Okay. So these studies come under the stoichiometry. See, for stoichiometry, what we are required? First, we are required balanced chemical equations. Okay. In balanced chemical equation, what are information they are providing? First, they are providing the number of moles of reactants involved in a chemical reaction and number of moles of product formed. See, in stoichiometry, we required a balanced chemical equation. Okay. In balanced chemical equation, what happened? What information we are getting? The first information we are getting that how many number moles of reactants are taking part, how many number of moles of product are formed. First, second, it indicates the relative masses of reactants taking part. कितने रिलेटिव masses जो है उसमें क्या कर रहे हैं बेटा, रिएक्शन में पार्ट ले रहे हैं. And what are the relative masses of product are forming during the chemical reaction. Other thing, if there is a volumetric relation, so it indicates the relationship between volumes of gaseous reactants and products at particular pressure and temperature. So these information we are getting from the balanced chemical equation. For example, suppose I am giving you H2 plus O2 is equal to, when we are forming water, when we are balancing this equation, what happen? We will here multiply 2, the oxygen becomes 2, here we will multiply. So this is the balanced chemical equation. So from balanced chemical equation, what information we are getting? First information we are getting what? 2 moles of hydrogen. 2 moles of hydrogen taking part in reactant 1 mole of oxygen. In reactant 2 mole of hydrogen reacted with 1 mole of oxygen and they are forming 2 mole of water. So this information we are getting from balanced chemical reaction. By balanced chemical reaction, what we have information we have got it? 2 mole of hydrogen reacted with 1 mole of oxygen and they are forming 2 mole of water. One more thing, relative masses. If we will go for the masses, 2 mass of hydrogen, suppose 2U, or per mole if you will go, so 2 into 2 gram, so 4 gram of hydrogen reacted with 1 mole has oxygen O2, 32 gram. 32 gram of oxygen and they will form how much? 2 plus 16, 18, 18 to the 36 gram of water. So one more formation we have seen. 4 gram of hydrogen reacted with 32 gram of oxygen and they will form 36 gram of water. So this also we are studying in stoichiometry. If one mass they have given, suppose they have given mass of water, how much oxygen we require, so we can find by the help of balanced chemical equation in stoichiometry. One more thing, if suppose this is hydrogen is also in gaseous form, oxygen is also in gaseous form and water vapor we have formed, all are in gaseous form. We can also find the relation between volumes of gaseous reactants and products. How? Here you can see two volume of hydrogen gas will react with one volume of oxygen, and they will form two volume of water vapor. Three informations. Number of moles we can find with the help of balanced chemical equation. We can find the relative masses which are taking part in the reaction and how much they are forming, and also we can find at a particular, suppose we can take also STP, standard temperature and pressure, or at a particular temperature and pressure we can find what are the relation between the volumes of gases of reactants. Remember one thing, it will not happen that two volume reacted with one volume. Suppose 2 liter hydrogen I have taken 1 liter. For example, boys are confusing कि 2 liter hydrogen we have taken, 1 liter oxygen, so they will form 3 liter of. No. This relation we are finding by balanced chemical equation in stoichiometry. 2 liter of hydrogen react with 1 liter of oxygen and they form 2 liter of water vapor at STP. So there should be no confusion. These data we are getting from the balanced chemical equation in stoichiometry. See, here one problem is there. The hourly energy requirement of an astronaut can be satisfied by energy released when 34.2 gram of sucrose are burned in his body. How many grams of oxygen would be needed to be carried in space capsule to meet his requirement for 1 day? Suppose one astronaut has gone, okay, how much oxygen required there, okay, to balance his diet in a day. So what they have seen practically, 34 gram of sucrose are burned in his body. So by balanced chemical equation in stoichiometry, we are finding how many oxygens are required. To see here, burning of sucrose. What is balanced chemical equation? Firstly, we see burning of sucrose. Chemical formula of sucrose is what? C12H22A11 burned in the presence of oxygen. They are forming carbon dioxide and water. Balance the equation. This is H22. How many hydrogen is here? 22. So how many water will form, molecule will form? 11 2s are 22. Firstly, balance the equation. See, carbon 12 here, it requires 12 carbons. So how many oxygens will? 11 oxygen is here, plus 12 2s are 24. So this becomes 35. Here we can see 11 is there. 11 cancel, you can say. So here how many oxygens molecule will form? Moles will form 12. So this will be the balanced equation. Sucrose reacted with oxygen, they are formed carbon dioxide and water, and energy will release. So see, what will 1 mole reacted with 12 mole of oxygen, they are forming 12 mole of carbon dioxide and 11 mole of water. In 1 mole, how many grams? What will be the molar mass? You calculate molar mass of here. If you are calculating C12, C12H22O11. So 12 into 12, 22 into 1, 11 into 16, 144, 22. Calculate it. Okay, this has come 342. One mole mean 342 gram of sucrose reacted with what mass will be oxygen here. So you can see here 12 O2, 12 into 32. How much oxygen has come? 384. 384 gram. If you want to burn how much? 342 gram of sucrose, we need 384 gram of oxygen. So see it, for 342 gram of sucrose, how much? There is 384 gram of O2 required. For 34.2, what happened? For 34.2 gram of sucrose, how much oxygen required? O2 required. So that will divided by 10 here. Also we have to divide it by 10, mean 38.4 gram of oxygen required. So this they have given hourly energy, 1 hour. So what will be in the day? So for a day, what happened? So how many oxygen required in a day? So this is per hour. Hourly energy requirement they have given. So in a day, how much required? So in one day, oxygen O2 required is equal to 38.4 in 1 hour. In a day 24 hours is there, so we will multiply by 24. This will be that much gram will oxygen required to a astronaut in full day. Day and night combined, they will require that much gram. By stoichiometry, we can find, by balanced equation, we can find how much oxygen required. We have given this one example.